Here is the science briefing on clouds and precipitation. In this presentation, we'll talk about cloud droplet formation, warm cloud processes, condensational growth, cloud droplet collision coalescence, cloud types, and types of fog. As a parcel of air rises, it expands and cools. Cooler air can't hold as much water vapor as warm air. As the parcel continues to rise and cool, it reaches saturation, and that's when the relative humidity equals 100%. At this point, water vapor condenses on soluble, which are dissolvable, atmospheric aerosols such as dust, clay, soot, or sea salt, and these are called the cloud condensation nuclei, or CCN. The transfer from water vapor to a liquid, such as cloud drops, dew or fog, is called condensation. It's the same thing that may happen in the mirror in your bathroom when it fogs up when you take a warm shower. Cloud droplets are so small they float in the air. When billions of cloud droplets and ice crystals come together, they make a cloud. Here we'll talk about warm cloud rather than cold cloud. A warm cloud is a cloud that lies entirely below the freezing level. So the entire cloud is below 0 degrees Celsius or 32 degrees Fahrenheit. There are two mechanisms or ways for the warm cloud droplets to grow. The first is by condensation, and the second is by collision coalescence, which means to grow together. Once a cloud droplet forms, cloud droplets grow by condensation, where water vapor is converted to liquid. As noted by the diagram, with the size of the droplet in the vertical and time on the horizontal axis, the rate is initially rapid, but it diminishes with time with not much growth due to condensation beyond a certain time. Condensational growth is too slow to produce large range droplets. That brings up the next way that drops can grow. It is called the collision coalescence process, which is when droplets collide with each other and collect each other. As noted by the red line in the diagram, as this collision coalescence process occurs over time, the drop size can increase dramatically. So here is a diagram showing the collision coalescence process. In the top panel, large cloud droplets collect typical size cloud droplets of 0.02 millimeters. In the middle panel, as the cloud droplets grow into typical raindrops, they become much more efficient at collecting cloud droplets as they grow bigger and fall faster. In the bottom panel, as the raindrops grow further, they continue to collide and collect additional cloud droplets and grow into a large raindrop which has a typical size of 4 millimeters. Here are typical sizes of each drop, and the image is shown to relative scale. A cloud condensation nucleus, or CCN, is 0.0002 millimeters. A typical cloud droplet is 0.02 millimeters. A large cloud droplet is 0.05 millimeters, and a typical raindrop is 2 millimeters. Next, we will talk about clouds. They are classified by their appearance and by the height of their bases above the ground. There are basically three cloud groups: high, middle, and low. The high group has cirrus, cirrostratus, and cirrocumulus. The middle group has alto stratus and alto cumulus, and the low group has stratus, cumulus, and nimbostratus. Nimbo meaning rainy. Here's an image of the cloud family with cirrus type clouds at the high altitudes, alto type clouds such as alto cumulus and alto stratus at the mid layers, and stratus type clouds and cumulus at the lower elevations. Here is a photo showing cirrus clouds. They are high clouds. They're usually wispy, made of ice, and they are an indication of fair weather. The next are cirrostratus clouds. They are a thicker cirrus cloud and often form a circle or halo around the sun or moon. They frequently precede a storm system in the next 1 to 2 days. Cumulus clouds are instability clouds. They show vertical development. Altocumulus lenticularis sounds very complicated, but they are often found in mountain locations. They are a stable cloud formed by strong winds against a mountain. They create a lens-shaped cloud and are often accompanied by strong winds that mix down to the surface. The next are stratus clouds. These are uniform layers of clouds. They can appear dark and threatening, and drizzle or precipitation is possible with these clouds. Next, we'll talk about the different types of fog: the advective fog, the radiation fog, and upslope fog. Advective fog occurs when warm, moist air moves over a colder surface and generates condensation and cloud droplets as the temperature drops. An example is warm water from an ocean or lake moving over land. The next type is radiation fog. This occurs when the surface cools rapidly, allowing condensation to occur and cloud droplets to form. Radiation fog usually forms during cold, clear, calm nights. Finally, upslope fog occurs when moist air moves up a slope and cools, generating condensation and cloud droplets. Finally, you definitely want to keep your eyes on these types of clouds. These are funnel clouds, which are called tornadoes if the funnel reaches the ground. This occurred on a ridge near Eagle, Colorado. So in summary, we discussed how cloud droplets are formed, the condensational growth of cloud droplets, the collision coalescence process for droplet growth, types of clouds, and we also took a look at the types of fog. That concludes our science briefing on clouds and fog.